Hi everyone. So now in this video solution, I'm just going to take one question from your core subject from Gate Aerospace Engineering. That is nothing but aerodynamics, right? So my main objective is to show you this question solution where you don't need any sort of, you can say step-by-step solution. If you know the concept of dynamic similarity, okay, and drag, okay, if you know the concept of dynamic similarity and the drag, okay, then you can solve this question. So if you have studied principle of dynamic similarity, right, so you will be able to solve this question, right? So in this question was asked basically for 2 mark. Okay, you can read this question. This question is given in gate 2024. Okay, and again this question was cleverly designed. Okay, so it is desired to estimate the aerodynamic drag, okay, D on a car. Okay, car is there is a car. Okay, the aerodynamic drag is there, that is D on a car traveling at a speed of 30 meter per second. Okay, that is the velocity you have been given. But what you're going to do here is you're going to have the model of a car which is scaled by 1/3, right? So scaling factor is given 1/3. 1/3 scale model of the car is tested in a wind tunnel, and we have to follow, we have to obey, or you can say follow the principle of dynamic similarity. What is the meaning of following principle of dynamic similarity? Okay, so in this question you don't need any sort of step by step solution, right? So dynamic similarity basically is going to ensure that the major drag will be directly, you can say, proportional to the drag D on a car, on, you can say, full scale car. Okay, so you have to measure drag dm is going to be the major drag. Okay, that you will measure for the scaled, okay, scaled model of the car. Okay, so in this case you have to remember that. Okay, what you have to remember, so the dynamic similarity will be, the meaning of dynamic similarity is nothing but all dimensionless parameter which governs the, you can say, fluid flow. Example, you can say Renault number, Mach numbers. Okay, all these kind of numbers. Okay, they are dimensionless number or parameters. They will be remain same for both full size car as well as the model of the car. Okay, kind of model car. And if dynamic similarity holds, so I think you can recall your formula, that is nothing but drag force is given as what? The drag coefficient times 1/2 rho v square times the frontal area, right? So your CD is gonna be also same, right? It will be same for both car and the scaled model, and your fluid density is also going to be same. Your speed is going to be same. Your flow conditions are identical in both cases, right? So drag on a car and the model, drag measured on the model will scale proportionally based on the size. Okay, so we might think that what kind of confusion we might have is, the confusion might arise like this when thinking about size reduction. Okay, so it is going to affect the drag ratio. बट यहाँ पर एक सबसे जो क्लेवर हिंट दिया गया है इस क्वेश्चन में, क्या दिया गया है आपको, कि डायनामिक सिमिलरिटी, we have to follow the dynamic similarity that is going to ensure that, you know, D and dm are going to be proportional to each other, right? So D by dm is going to be equal to then 1. So answer for this question will be 1.2, you can say. So you don't have to solve this question, right? Okay, and I believe that you are familiar with this drag force. Okay, this is nothing but your drag coefficient. Okay, this is rho, fluid density, velocity, all these things, right? So whenever this kind of concepts is given, and this kind of pattern you will notice in gate examination, right? In gate aerospace engineering, right? Okay, so make sure that this question is highly conceptual. Okay, okay. So we'll meet in the next question solution. Okay, I hope you might have enjoyed this solution, session. Thank you.